Just this up. Hello.
Good morning.
How are you?
I'm good. How are you?
Good.
I'm glad I could join this morning. Looking forward to this.
I don't think we have anything specific scheduled today, but actually we have a bunch of papers and I mean it'll be interesting. Actually, people.
Good.
Hi, Ujjwal, how are you? Wait a couple more minutes for people to show up. Okay.
Let's see, I'll be back in just a moment.
Okay. Ujjwal, demo for your portal. Yeah, we can talk about it for about 10 minutes, maybe 15 minutes. You can just show. Well, we'll wait until other people show up, maybe. But we can put that on the agenda.
What is this video conferencing tool we're using right now?
It's a Google Meet, so it's I think the descendant of Google Hangouts. It's kind of like a special version they have for like business. I don't, I like kind of using that's free. I was thinking of switching to Jitsi, which is another platform, but I'm not sure if I'm going to do that yet or not.
There seem to be a lot of platforms I've been using. I'm having a hard time with Zoom. It's either it confuses me or I confuse it, or it's a mutual thing. I get really well.
Yeah. Zoom is I don't know. They've had a lot of security issues. So
yeah, I've heard that.
But other than that, it's not bad. It's pretty functional. When I have meetings in Zoom with people, it's usually pretty stable. But Yeah, and I mean, I guess how much is GoToMeeting usually in terms of like a paid version versus a free version? What is the difference?
I haven't noticed the difference except as far as the quality of communication. I don't see any difference. I've used both. I've got the pro version just because I like to start lots of meetings.
Yeah. Yeah.
It's not that expensive. Something like $240 a year.
Oh yeah, lawsuit filed about Zoom. There's a lot. Yeah, they just have like they have security issues with the if I think there was one incident where like people were popping randomly into other meetings because of some security flaw in the software. So it was stuff like that. So I guess there was some. Yeah, I mean someone probably says and stuff like that happens. People want to sue. So it's not
never happened on. It is something that never happened on Meet. I guess.
Yeah. There's Vinay. Hi. Can't really hear you very well, Vinay.
How about now?
Yeah, I can hear you now.
Yeah.
Yeah. So how are you feeling, Steve?
I'm feeling pretty good. I don't know how I'd feel without taking all the anti-nausea drugs they give me and all that, but,
Yeah.
but I feel fine actually.
Oh, good.
And after my first treatment, which is the only one I've had so far, was on Thursday. They pumped me full of steroids, and I felt like Superman.
Oh. Good. Yeah. All right. Well, we'll get started, I guess. Welcome to the meeting. It's Monday, of course, Monday morning. So we usually get a pretty good crowd. I mean, we'll record it for people to watch it later. We don't really have anything specific on the agenda today. I just wanted to go through a bunch of different things, a lot of papers that have been put out recently. We'll talk about John Conway, who died over the weekend, and I have some things there that are interesting. People have been generating in tribute. Then Ujjwal wants to do a short presentation on his he's been mocking up like website for the group, so we'll take a look at that. It would be a short mock-up session just to demonstrate it. So, any business we want to talk about before we get started? Any upcoming events or? Okay. Yeah, I just want to let people know if you want to present something, you can. We have a bunch of open slots in the near future. I'll probably present a couple more things, and we have our open weeks like today. So if you're interested in presenting on something, it doesn't have to be very long or very formal. Just contact me, and we'll put it on the schedule, and then we'll publicize it. So let's see. Let me present now. So maybe first what I'll do is I'll go over the major tasks. That's something we do every couple weeks. And we want to get a sense of where we are with different projects. So here's the project board. I'll put it in the chat. is, of course, hosted on GitHub. Okay, so we have a bunch of things that actually we've done. So let's look at what we finished here that have been on the board. We had a blog post for Open Data Day. That was a while back. That was the Open Data Day for 2020 for DevoWorm affiliated things. Create OWDW curriculum on Google Scholar. We talked about that last week. That was an educational update to some of the materials we have. Jesse's presentation on natural selection finds natural gradients. That was completed several weeks ago. George Mikhailovsky gave a presentation on structuredness and entropy. Of course, I think all of you were there for that. Virtual Worm 2020 participation. So this is a presentation to a virtual group of C. elegans people that is going to happen maybe this spring or summer. This is something that we can go over maybe in a future meeting when it's actually on the schedule. So I have some ideas of what we might put in that, but we might also talk about, what we might. It would kind of be a showcase of DevoWorm, but it would focus on topic. So we can talk about it later. The Google Summer of Code deadline. So Google Summer of Code is actually ongoing. The deadline for submissions was March 31st. So we got those. Now we're evaluating those applications, and we should be making a decision in the first week or so of May. And then we'll have the community period. So whatever the we'll put that on the schedule when we get a little bit further along in terms of the community period. But the plan is to have people attend the meetings here, and then maybe have a separate meeting right before or after for specific issues. So whoever the Google Summer of Code people are, talk about specific issues that they might have. And so it's always good to have, it's like a code review type thing where you do something over the week and then you review the code. And because they're being paid for this on a tight schedule, you would have to do a very succinct review of your work. So we'll put those on the schedule though as we get closer to that time. And then, of course, Ujjwal presented on his progress on CompuCell 3D. And so those are all finished. In progress, we have a number of things here. We have the axolotl embryo animations and segmentation. So that's number 25. We don't really have it assigned to anyone. I think Ujjwal was showing me some animations he's done, so maybe that's something we can update in the near future. And then to make Google Summer of Code selections, that's something that is going on. We can't publicize that at all. It's going on in a separate channel, but that's ongoing. Game theory for developmental processes. So that's a paper that right now I'm trying to negotiate with someone to write this. It's kind of a review of different game theory models, developmental biology, and grows out of some of the work that we did in some previous papers. So I'm kind of negotiating. We'll in the near future talk about what that involves if people want to contribute different sections to the paper. But I have to get it. You have to get at least to a rough outline before you propose that someone can work on a paper. And that goes for anyone here. If you want to write a group paper, if you want input from people, please propose something. You can write an outline and show it at the group meeting, and people might agree to contribute some sections. We were doing that in a prior meeting with the Basilaria behavior paper. Just kind of like it has an outline, and we usually do it on GitHub or in Google Docs. So if you have, if you want to do it in Google Docs, fine. You can do it on GitHub where people just put text or markdown in a file and push their pull request to you as the leader of that paper. That's up to you. But, this is a sort of collaborative paper we like to do in this group. And so that'll come in the near future. Create DevoWorm ML on Google Classroom. This is a little bit behind this one here, number 23. But again, that's probably should be put in finished, although not really finished with putting the basic outline together on that. CompuCell 3D model for C. elegans development. That's associated with this thing that Ujjwal presented, so maybe we'll get some future updates from him on that. Schedule presentations. It's open. This is the paper I was telling you about, the bacillary non-neuronal cognition paper. The Embryo Physics Archive, which is another education-related thing. It's a bunch of lectures, and I showed you that last week. We had a discussion on that. The review axolotl data on the USB drive. I showed that last week. That was from Susan. That maybe should go into finished, but I'll think about that. We still have to do some further discussion on that. And I didn't bring so Dick, after the meeting, he sent out a paper. He put a paper in the chat, a link in the chat on this idea he had about Google Embryo. And so I don't have that paper right now, but I can send a link out to people after the meeting. So about 10 years ago, he wrote this paper about like a Google embryo, which would look like Google Earth. Get surface of the embryo or sections of the embryo and plot them out in a browser, just like they do with Google Earth. So the surface of the Earth is, you can go across the surface of the Earth with Google Earth. You can go, scroll across different topo-quad map sections, and they're presented serially, and they're presented on a sphere. And that was the idea behind Google Embryo. And so it never really came to be as an artifact, as a software artifact, but that's something that we now have this axolotl data that Susan presented, and it's a special type of data where the embryo is flipped in the course of imaging. So you start at the bottom, the embryo is flipped over, and you get the entire sequence from top to bottom, or from bottom to top. And so I don't know if we can do what Dick wants with it. I mean, we're trying to figure out ways to do that. So it's a nice vision. We'll see if we can do it, but we're still working on that. So I didn't really follow up on that from last week, but I think that's something that we can talk about some more and maybe get something going on that, get some momentum. So for the hold tasks, we have reorganized DevoZoo, and I think Ujjwal is going to show a little bit about that today and his sort of ideas for reorganizing that portal. But there are other things too. This is just, this is something that can be broken into several tasks. This paper for the special issue of Entropy, Complexity in Nature. This 17 is linked actually to this 24 as Game Theory for Developmental Process. So this is something that's still really embryonic, pardon the pun, but it'll be more clear in coming weeks. Other papers, like I said, we have a couple of group papers that we're contributing to, so maybe, and I don't have them today up and ready to go, but we should make an inventory of those papers for people to maybe contribute to. Maybe that's a good thing for like a GitHub, like maybe a README in the group meetings. So it's in this repo here, DevoWorm group meetings, and I just create like a list of the outstanding group papers, just so we can keep track of them. And then, people can be invited to them if they want to work on something. So we'll have maybe, like something like a markdown file where we'll have links to each paper, Google Docs or GitHub, and then you can request access and then make your contributions. I don't want to make it totally open because you never know who might decide to, put some garbage in the paper, just as a malicious act. But you can request access to it. So that might be something to update here. I'm not updating them in real time because I'm not on the right account here. But the axolotl montaging, that's related to this number 14. So the axolotl data needs to be montaged. So we need to take the images and create tiles or flat surfaces or something that we can translate from that sphere that we're imaging in 2D to this flat surface map that would give you this ability to navigate it. I don't know a lot about that sort of technology, but that's something we're going to try to do. It's maybe something we'll have to try to find some people to do, or if they're interested in collaborating. Like I said, that axolotl data is really interesting. And then this model for biological living networks paper. This is, again, something that is another one of these open papers. So yeah, we'll add to the list of open papers. And then so to do. This is a lecture I wanted to give on some work that I was doing with someone on artificial embryos and modeling embryoid bodies and things like that. It's kind of an interesting thing, but I'm not really there yet. There's some other things here. The CT computed tomography via cloud computing. This is a question that Dick posed a couple weeks ago to the group, and no, I took him up on his offer, but it still stands. I think in one of the group meetings on YouTube, there's a bit about it where he talks about this challenge that he has for people to be able to. He actually wanted people to think about it in terms of machine learning. So there are a number of people doing machine learning in the group. Oh, there's Dick, who might be interested in contributing to that. Hi, Dick.
Hi, Dick.
You're muted.
I had a call from China that was late. Okay, so just 4 of us today, huh? Okay.
Yeah.
Okay. Well, I'll let you present. I'm getting better.
Oh, good. Yeah. Well, I was just finishing up the task board, and then we're going to move on to some things here, papers. So congratulations on the paper you did with George, the new paper.
Oh.
Yeah.
Okay, yeah, we're working on another one.
Oh, good. Okay, and then just to finish up these tasks, there's another lecture I wanted to do on some statistical methods. I'll do that in a couple weeks, maybe. There's this thing of complexity measures, which I found in our files from a long time ago. It's something that if we'll talk about, if someone's interested, we can pull up this issue and talk about it in a future meeting. They're just measures of measuring complexity in development or in embryology, and I think we're actually talking about this in terms of diatoms, but I can pull up our notes on that if anyone's interested. And then, of course, the embryo visualization for Docker, that is a open issue. We talked about this in a previous meeting where we wanted to create a visualization for the OpenDevoWorm Docker file. and ideally it would be some sort of program that would be executed in their Docker file, but it could be just an animation. So I don't know what our progress is on that. A couple people expressed interest earlier, but if you want to give an update on that, you can. Let's see. Yeah, encourage Rob Stone to write up a history of cybernetics. Yeah, I'm actually talking to him later today, so I'm gonna give him a call. We'll see what he's up to. Yeah.
Okay, good.
Yeah.
Yeah, he needs something to do, and he did an excellent job, and then I took most of it out of the paper we did on cybernetic embryo.
Yeah. I'll encourage him. Yeah, we've got I think he's got some time here to.
Yeah.
So so that's the major tasks. Now I wanted to get to the papers next. So let's see. So we have a couple of papers. First of all, maybe I wanted to have a discussion with Dick about the paper that they just published in Biosystems. So this is the one here. It opens up. Okay. So this is the new paper. Shuffling type of biological evolution based on horizontal gene transfer and the biosphere gene pool hypothesis. So you want to genes persist, species don't. Is that the lesson of the paper?
I think so. At least
Okay.
to me, yes.
Let's see. Why don't we go? Let's see. Why don't I go through the abstract? I'll read it and then we'll talk about it a little bit. So widespread horizontal gene transfer may appear a significant factor that accelerates biological evolution. Here we look at HGT, which is horizontal gene transfer, primarily from the point of view of prokaryote clones, which we take as descendants of a single cell, all who have exactly the same nucleotide sequence. Any novelty that emerges as a random mutation, creating a new clone, could either disappear before its first transfer or survive for a period of time and be transferred to another clone. Due to the chain character of gene transfer, each gene with an adapted mutation is thus spread among numerous existing clones, creating further new clones in the process. This makes propagation far faster than elimination, and such genes become practically immortal from a kind of biosphere gene pool. Not all of these genes exist in every clone, and moreover, not all of them are expressed. A significant fraction of biosphere gene pool genes include genes repressed by regulatory genes. However, they're expressed often enough to be subject to natural selection. And so they talk about this mechanism for testing repressed genes for adaptability can be thought of as shuffling a deck of genes, by analogy with shuffling a deck of cards. In the Archean and Proterozoic eons, both BGP, which is this biosphere gene pool, and the operational part of each genome was rather poor, and the probability of incorporation of randomly expressed genes into the operational part of the genome was very small. So accordingly, biological evolution during these eons was slow to advance due to rare adaptive mutations. So this explains why the realm of prokaryotes, as the sole organisms on Earth, lasted so long. And so this is this question of like the sort of the temple of the tree of life, where you get some major division in the tree, and then it takes a long time for another division to happen. And then the question is what controls that timing? And so we suggest that multicellular eukaryotes that appear at the end of the Proterozoic eon could shuffle the genes accumulated in BGP, which is this biosphere gene pool, through gene transfer from prokaryotes that live in these multicellular organisms. Perhaps this was the cause of the Cambrian explosion and high increasing rate of evolution of the Phanerozoic eon compared to with the Archean and Proterozoic. So this is again with the temple of evolution, and let's see. This is a pretty, I mean, I imagine it's a pretty dense paper. I've read through it a little bit, but in terms of the... So is this something that used simulations in it? Looks like there were some simulations run. So these are a lot of the approximations that they're using here. So they're using a number of estimators here to generate these graphs. So the rate of biological evolution by era. So you can see that the argument is that there's a relatively low rate of evolution for most of the history of early life, and then as we get into the modern era, which would be considered to be after the Cambrian explosion, you see this increase in the rate of biological evolution.
I have a question here.
Yeah.
How would you measure the rate of evolution?
Dick, do you have an answer, or is it?
I've been out of it for a month.
Okay.
We'll search on the word rate in the paper.
Yeah. So let's see.
Rate of biology.
Yeah. Imagine though the
Well and rate is the relation of the sum of characteristics of all the eras. It's in the caption.
Yeah. Okay, let's see. So the caption. Let's see. Here we go. Okay, relative rate, which is the y-axis here, is the relation of the sum of duration of all the eras, total duration of the existence of life t on Earth, or 4 billion years, to the duration of each era. In other words, then he gives an equation here, r sub I equals t over d sub I, where r sub I is the rate of evolution in the ith era. So each of these eras, so it's a fractional measure. And then di is the duration of the ith era. So it's like weighted by the length of that era. And then the durations are taken from table 1. So the idea would be basically that there would be like an accumulation of changes and then over a certain time period. And then you would calculate that rate. And then that there's a relative rate, which is like, compared to like the other eras. It's kind of a normalization factor, I imagine. And then that's how you end up with this graph. And so, people usually measure rate, if they can't get like a molecular clock, and I'm talking about in like a, like maybe a molecular study, they can't get a molecular clock, they'll just maybe make an estimation from like maybe the time of a common ancestor, and they'll sort of, calculate how many mutations are present in each descendant species, and then that calculates a rate. I mean, there's a lot more to it than that, but that's basically the way people usually do these calculations in an empirical context. In something like this, you can calculate the number of changes over a certain time period and find like a rate. It's really, we don't know for sure because it's, mutations are random. So you get things happening. You could get a bunch of mutations happen within 100 years, and then maybe very few for a couple hundred more years, and then, but we have this sort of clock that we're trying to construct to say this is the rate of evolution. But it's, it's a heuristic measure because, they don't happen like clockwork necessarily. It's, It's a random process.
Right. Okay, thanks.
Well, see what that.
So let's see. So that I mean that's so I mean it's pretty dense to like go through a 5-minute presentation here, but they do give some possible consequences of random mutation here. So they talk about some of the things that happen in with respect to random mutation and horizontal gene transfer and selection. They list the consequences of a mutation of a gene, which we designate as a novelty, that appears in a prokaryotic clone and generates a new clone. There can be 3 and only 3 consequences. And then they talk about those consequences, and then they talk about horizontal gene transfer being a chain reaction and the immortality of adaptive genes. So these genes get propagated through horizontal gene transfer, and if they're adaptive, they become proliferative and they stick around. Let's see. They talk about a double explosion of new genes. So the double explosion refers to each step of HGT is a genes bomb. In a genes bomb, never heard that term before, but it's related to the atomic bomb. So basically, horizontal gene transfer is this chain reaction, and it leads to some sort of explosive process, and that's where this adaptive radiation occurs of some type. So this is a double explosion of new genes. I mean, I like the language here. It's kind of interesting. I don't know. I mean, like I said, you have to get into the paper to know to appreciate it. But so this is a graph. This is a tree graph of the 2-dimensional double chain process of spreading a useful gene. So this is from a single clone, and now it's spreading out to other clones. And this is this process sort of put into a tree version, a tree visualization. So biological evolution is shuffling of the deck of genes. So they talk about this process of shuffling. So this is something that happens in stochastic processes. So they suggest 3 categories for horizontal gene transfer in prokaryotes. A is a repressible gene in clone A is copied bare to clone B, resulting in clone C with that gene not repressed due to no regulatory gene for it in the genome. So you transfer a gene and then it either can be regulated by the existing machinery or not. So that's irrepressible. Or B, a repressible gene in clone A is copied with its operon to clone B, resulting in clone C with the gene that can be repressed or expressed. And then C is a gene with a promoter but with no operon in clone A, and thus never repressed in A, is copied bare to clone B, resulting in clone C with that gene not repressed. And so there are a couple of options there for genes being moved by horizontal gene transfer. Do they fit into the genome or not? And so the shuffling, of course, is the characteristic time of such shuffling is determined by one of the HGTs that we already estimated is on the order of weeks or even just hours. But that estimate relates to the transfer between individuals which were not spatially separated. And so there are a lot of things to take into account, but their model basically shows this kind of shuffling process and how when you shuffle genes between genomes, you have a couple of different outcomes potentially. So this is sort of a diagram here, figure 5 of these phases of shuffling. So you have gene transfer inside of an ecological niche, and then shuffling among ecological niches, and then you have this sort of arrangement here. So on shelf means a set of structural genes and operational part of each genome that belongs to clones from the same ecological niche. In stock is a set of all potential operational but repressed genes and genomes that belong to clones from the same ecological niche. And in assortment, set of all potential operational genes in the biosphere gene pool. So that's what those different categories mean in the circles. Alright, so then some final remarks, and they kind of tie it up to make some conclusions about novelty. Any novelty which they define as a useful genetic mutation can have only three consequences. One is the gene appears to be a pseudogene that does not have protein coding ability and can exist and even be horizontally transferred, but is invisible to natural selection and evolution. Two, the protein encoded by the gene appears to be harmful. All the descendants of the mutant die before the first horizontal gene transfer, and the gene is eliminated. And three, the protein encoded by the gene appears to be useful, and the gene can be transferred to another clone via horizontal gene transfer. So it's either eliminated if it's harmful, or it's incorporated and starts a new clonal line if it's not harmful. And so these are kind of things that sort of apply to mutation in general, I guess. But we're talking about these genes that are transferring and maybe starting new clonal lines. And so this is a really good paper. I liked it. I hope maybe, if someone wants to present on it, they can, if they want to go longer on it. And that just includes anyone in the group if that's something that you want to do. But it's a good paper. I like it. It's very dense because, like those dense papers where there's a lot of theoretical content packed in the paper. So it's good. Now I think I want to move on to this John Conway material. So John Conway was a mathematician. He died this weekend, and people immediately created some tributes to him. So John Conway was a mathematician who developed the game of life. So if you're familiar with the game of life, which is a cellular automaton, that's what he was best known for. But he actually has a lot of other mathematical proofs and ideas that he was responsible for. So he's got a pretty long list of things that he did in his life. So he did this. Let's see, find the first one. So this is someone's rendition of the game of life on a sphere. So you can see that there's this grid of it's a cellular automaton, and it exists on this grid. And the game of life is where each of these automaton cells, or each of these automata, have a state. It's either on or off. And so you can turn each of these cells on or off, and you compare it with neighboring cells in terms of the state, and you end up with these patterns that emerge. And so you get not only pattern formation, but you ended up with, it revealed types of movement. So you had things that moved across the automaton, as well as just emerged as a pattern. So one of the most famous patterns was the glider. So the glider was something that looked maybe like a bird or like some sort of thing that had a wing. It's like you could play pattern matching games, but the thing moved across the array. So not only emerged as a pattern that you could recognize, but it would move across the array and exhibit these sort of lifelike behaviors. It's really interesting. It's a really interesting platform. There are a number of different software instantiations of this. I'm not sure what this is. Oh, this is a movie of him tying a knot with his hands. So he was into knotting, which is a mathematical concept as well.
This, I'm sure, was in Martin's column sometime. you know, it's impossible to tie a knot without leaving go of the ends of the string the way I just did.
So he, like, the study of knots is a mathematical area in and of itself, and he contributed in that area. This is a cartoon. This is the game of life. So this is, again, hey, one of the lights went out. It wasn't supposed to do that yet. So the lights are the cells that are turned on in the array, and the blue cells are the ones that are turned off. And the idea is that these change dynamically over time, and it changes the sort of the patterns that emerge, and their movement and all this other stuff. So it's that was a play on his game of life. Let's see. This is another cartoon that I have here. So one of the things about the game of life is it's not only a nice simulation of life, but it's something they call a zero-player game. If you know anything about game theory, this is something that's a zero-player game as opposed to like a one-player game or an n-player game. So chess is a two-player game. One-player game is something like, I'm trying to think of a good example of a one-player game, like a game against nature, where you're maybe trying to predict what a slot machine is going to do or what the weather is going to do tomorrow. And then this is a zero-order game, or a zero-player game, where you don't actually have a player per se, but there's a game theoretic formulation you can make. So you have cells that are turning on and off against a stochastic background. And you're just, as a player, you're actually, as someone who, you're just an observer to the game. You don't play the game. These cells are playing a game against nature. And so it's a zero-player game. And so this is a nice cartoon where it kind of demonstrates the game of life. I don't know who drew up this comic. I don't have the attribution right on this, but I think you can reverse Google search this and find it. So these are the gliders here, and they kind of show you the process that goes into making a glider. It's good stuff. Finally, let's see. This is an animation of the game of life here. It's a GIF, so it might take a while to load.
I wrote a simulation of the game of life in Excel once.
Oh, really?
Yeah.
Yeah, it's always a fun thing. I think it's a fun activity to do. It's really something that has a lot of payoff when you write the simulation. Oh, there's all this great stuff coming out of it. So it's really fun. Yeah, I can't get this to run, but it's oh, there we go. So this is what it looks like in real life when you run the simulation, and you can write it in different languages. So that it's some sort of pattern propagating. And there's also movement, and you get gliders, which aren't necessarily shown here. Maybe these ends are gliders. I don't know how you classify them. But that's what it looks like. So it's really fun. And, so there's the game of life and its mysteries. People have written a couple of papers on it. One is that we have this is one that I found in the Artificial Life Journal. The cognitive domain of a glider in the game of life. So this is arguing that you have this sort of cognitive domain that you can extract from the game of life. So they're just looking at a glider in the simulation, and they take an autopoietic perspective, which is something that is a derivative of cybernetics. And this is a study on sort of the cognitive domain of a glider in the game of life. And, so they go through autopoiesis and cognition. They go through the glider autopoiesis, so it's like a process that's, sort of, if you're familiar with embodiment, it has to do with that. So kind of walks through this cognitive domain. So there's In an empty environment, gliders undergo an endlessly repeating sequence of state changes determined by their own intrinsic dynamics. However, a non-empty environment can perturb the sequence in various ways. And so in the autopoietic framework, an entity's cognitive domain is a set of all interactions in which it can participate without loss of identity. The goal of this section is to completely characterize this cognitive domain. So it goes on about this domain, and it's a pretty good paper. If you're interested, you can follow up on it. Kind of goes over the behavioral trajectories of a glider as well. And then finally, there's a paper, and this to give you an idea of the diversity of studies surrounding the game of life. This is Game of Life and the Epigenetic Principle. So this is where they study this to look at, explore the evolution of ecological communities. So they apply it to other biological processes, including symbiopoiesis. So that's a version of autopoiesis. We show that Conway's organization of rules reflects the epigenetic principle, that genetic action and developmental processes are inseparable dimensions of a single biological system. And so they look for similarities and differences between two epigenetic models by Turing and Edelman as they are realized in the game of life objects. And so this is more a developmental biology type application of this, but they walk through their explorations here. It's a way of looking at this. So this is all. I can share this repository with people in the chat, or if you're watching this online, you can send me a message, or you can send me. You can look at it. You can send me a message. I can send you the link. So we have. Let's see. We have some here. I'm going to present on this today. I want to go through the chat, and then I want to give you all a chance to present. So can I enlarge the view of the paper? I couldn't really get it to do that in Google Docs. Dick says next paper will include simulations. Would be neat to try following specific genes across dated species. Please send me the published paper. Dick says ask George. Yeah, George probably could give some answers to this too. Janice Pappas gave the course on knots. Yeah, she's a collaborator. She's a mathematician. And then Solitaire is a one-player game. Yes, Solitaire would be a one-player game. Where you're playing against anytime you play against a machine is a one-player game, technically. And then Steve is going to leave in a couple minutes here. So thanks for attending, Steve. And then send a link to the cognitive domain. I'll send out a link to that directory of things. So, all right, Ujjwal, you want to present on your things? If you need to leave early, it's okay. I'm recording this, so it'll be available to everyone. So, thanks for attending. If you have to leave early, so Ujjwal, could you bring up your screen?
Oh, yes, sir.
Yeah.
So, I have tried to develop a portal for the DevoWorm AI Center. That this is the thing which is long pending, and we all are trying to get the things done on this. So, this is the main page or main front page which is going to be there for the users who are going to interact with our portal. So there's a front flash page which says open source initiative to create first organism. Then there are a couple of models that we have developed with time, some C.elegance image models which can be applied there. Also, there are models like digital basileia. We are also aiming for making some general segmentation models, so this page dedicated to that. This is the Devo method that the sir is talking about. He organized the Devo Zoo, so this is one of the main factor is going to play an important role in that. So as you can see, all the DevoZoo and Devo methods implementation and dataset can be listed here, and they can be there will be a dedicated page for each of them so that the user can get more and more information about all these. Then the DevoWorm Academy that we are talking about. So this is a open source course initiative that we are trying to get through. So this page focuses on that. It will be updated as soon as we get daytime Google Classroom classes. So this is a little bit of history about DevoWorm. So like how this whole thing has been started and how the Dr. Stephen and Dr. Bradley all have met and they have started the DevoWorm. I'm also making a kind of interactive game which you can play on web using your arrow keys. I'm working on that. It will be completed by the end of this week. These are the just numbers, like to give a broad overview about what we do here, what are our skills, and what we have done till now. And the latest research paper will be linked here so that it can be easily accessible. This is a bit about founder, like and the DevoWorm ML advisors and team. This thing has to be updated. Like I have include the name of those who frequently attend the meeting. So this thing will be updated as soon as I get the data. Then there is the contact us page. Like if you have any query regarding anything, you can directly contact to us. So this is the one scroll JS implementation that I have implemented in this. Then there comes a whole menu for that. You can see the models, feature, message area, segmentation rule, etc. Let's go to c.elegant for instance, and let's try online tool. As you click to try online tool, you will get to our DevoWorm center login page where you can enter username or password if you are already registered, or you can register through that. The registration uses also Google and Apple ID, which I will also integrate within a day. So let's say like I have made a simple account. So if we go, so you come to a profile page where each and every person get a profile page for him where there are all the social links related to him there. This should be set, and edit profile options will be there, dashboard option will be there. So as you can see, like your feed, this is the innovative part that we have discussed, and here we can update all our DevoWorm ML meetings, all the papers that are going to be published by our group, so that the user who is using our portal will be stay updated about all our progress. So like this, if he wants to submit, if he has some suggestions for us, if he wants to collaborate on one of the thing which comes up in his feed, he can directly send us the message. So let's see what happens when we create the new data set. So this is something where you can choose a model for your data set which suits best. So like right now, we have two kind of models, a oval shaped or something, C.elegance model, and a rod shaped like Basileria model. So whichever resembles to your data, you can just go and see that. Like if you have a more oval and circle type data, you can apply this model or this model. Also, I am trying to integrate the steps for the pre-processing which are needed for the process for the pre-processing stage of the model. Like there are certain steps which are need to be done, like making ground truth tables for the images and making masks for the images to train your deep neural network. So I'm also going to add that up. So as long as you choose this, so you come to a C.elegance tool. So this is something where you can browse and submit your image. So right now it is not connected anywhere. So you can select anything. It is not uploaded because it is not connected to a backend server right now. It is front end all. So once it is connected to backend, it will become green and shows your confirmation like yes, your thing has been uploaded. You can click on submit. Here the results of an image will be there. Like you can download the output image in CSV. So these were the images. This is one of the result image that is produced by Vinay Varma. during his project in 2019 GSOC. So there are the different options like view charts, view metrics, tweak parameters. So if we click on view charts and view tweak parameters, so this is the dashboard. It is not completed, like we don't have any metrics yet, but it is a overall design like how it's gonna be doing. And there are two modes for that. And also in the tweak parameters, you have a filter. I am going to give multiple options to edit the image. You can zoom in and zoom out the images through your mouse scroll. Also, there are many options like hue, contrast, zoom in, zoom out, grain, model filters like Sigma Radiant, grayscale, epochs, pixelate, and thresholding. This is a static page right now. I have not connected all the components of it. And there is a draw contours tool where you can pick up a color and draw yourself if you want like something more detailed. So it is an overall build up package for image editing as well. So you can edit your image, you can tweak your parameters, all things in one stop. Then this is what I have accomplished right now, and I am now right now working on making 3D models for C.elegans and the Basileia model, and will try to embed it in the website itself so that a person can view in 3D all the models and all the growing stages of Embryo. Uh, so like this is the update from me. Like I particularly want to get your reviews on it, and especially on these two. These two are the main part of the portal where you can edit your images, you can adjust filters, etc. So I will appreciate if you can give your reviews on that.
Yeah, I mean, thank you for the presentation here, short one. Yeah, if people want to, you don't have to comment now, but this is sort of the thing that Ujjwal was proposing for changes to. So this would be kind of a new face to the. So it wouldn't really be like revamping the DevoZoo. It would be sort of like putting a fresher face or a more expansive face on the on the DevoCell.
On the one website, and also like providing much more detailed pages for the each data set so that a person can have a really quick view of what data set is, what are the type of sample images contained, and brief history about all the data set parameters and photos.
Yeah. So I mean, I like the idea of having this sort of pipeline, or well, the pipeline aspect, but also having like a pre-processing steps and maybe some interpretability, which is, of course, I think we talked about in DevoWorm ML, where you're trying to make sure that when people use this tool, because this is more of a community endeavor, people will come in and want to contribute, and they'll, want to do some data analysis perhaps to make it as transparent as possible. So if we have a set of images and they want to, analyze them, we can plug in a new module. So if we want to do something with, test a new type of algorithm or try out some new techniques, or have some images that are, it's really hard to classify what they are. Biology is very diverse, and so sometimes it's hard to figure out which algorithm to use.
For this, like I have given a thought on that, and I come to a conclusion like in the GSOC project, like I'm going to make a Python library after all, so we can make a static Google Colab pages where we can import our own library, and we can show them like these are the steps you have to go through, and these are the pre-processing steps where they have to just click on the run button after uploading images, and they get all the pre-processing and they get final output. So it is not going to be the final output that they are going to get, but it is a kind of test and try. Like you can, if you are getting a very far away result, like what you are expecting, so you can switch to a next model. And if you are getting somewhat similar results, so you can go ahead and apply it on our portal.
Any other comments from people?
Yeah, so I really like the idea that he's proposed, and it's so good to see the UI the UI design, and it's yeah pretty good work from his well.
Thank you, Vinay.
Yeah. Dick, do you have any comments?
I think like sir has left the meeting.
Oh, okay. Well, yeah, he he's a background in imaging, but I mean, it's not,
So
I
like
mean, yeah.
I have also one question like do we have this .cgi files for CZI files for the models that we have like Basileia and uh, like C.elegance like the microscopy files which comes like in that format only.
Uh, well, yeah, I don't know. We usually have like, yeah, there are like certain types of files you can bring in. What I thought, well, usually the input format would be some sort of generic movie or some set of images. So it would be a pretty generic format. I guess we could cater to like proprietary formats, but it's a little harder to work with. So I think maybe just to make like a standard and say, you know, you have to use, some sort of generic movie format or image format, and that would be the way to input data. Because there are a lot of different like specialized formats, but I don't know how hard that is to support.
Okay, sir. Thank you.
Yeah. So Dick, did you have any comments on this, or did you see? Okay, so Vinay has to leave. Okay, have fun, Vinay. Thanks for attending. Okay, has this been submitted? Oh, the diatom. Yes, we sent that over to. Yeah, that should have been sent to what's his name a while back. I don't know. Yeah, I don't know. I mean, as far as I know, yeah, he sent me a confirmation email on it. So, and then we're waiting comments on it from people. I sent him a list of reviewers, and we'll see. It was a while back, like maybe I do have a missing month. Yeah, it was like I think it was back about a month ago. So, well, okay, I think that's it for today. Thank you, Ujjwal, for presenting. Thank you for attending, everyone. I hope you're doing well, Dick. I hope you feel better. You're feeling better. Okay. All right. Talk to you guys next week. Yes, you too. Thank you. Bye. Local recording.